find the equivalent resistance of the network shown in figure between points A and B. Now in this we have R and R in series, so we'll get 2R. This 2R is parallel in R, so let R dash equivalent is given by 1 by R plus 1 by 2R, that comes out to be 2R by 3. This 2R by 3 is now in series with R, so R double dash equivalent will be 2R by 3 plus R, that comes out to be 5R by 3. This 5R by 3 is now in series, now in parallel with this R, so final R equivalent comes out to be 1 by R plus 1 by 5R by 3, so R equivalent comes out to be 5R by 8. That is the answer. In B part, if we redraw the diagram, we come out to be, let this point be A, let's say this point is 1, this point is 2, this point is 3, this point is 4. So I have A, and from A to 2 we have one resistance, this is my point 2. From 2 to 1 I have another R, and from 2 to 3 I have another, this is my 2 to 3, this is my point 3, this is R, and 1s3 is connected directly. And from 2 to 4 I have another, this is my another R, this is my point 4, again 3 and 4 is connected directly, and this is my point B. So what I have to calculate is the net resistance. So clearly that this R and this R is in parallel, so circuit comes out to be an R, and R by 3, this is my point A, this is my point B, because R are in parallel, so this R and R by 3 are now in series, so R equivalent comes out to be R plus R by 3, that gives 4R by 3. That is the answer. In C part, clearly it is a Wheatstone bridge. Let's say this point is 1, this point is 2, so I can get that resistance R1A divided by R1B is equal to R2A divided by R2B. That is a condition of a Wheatstone bridge, and that is equal to 1. So net resistance can be calculated by eliminating these two resistance. So if these two resistance are eliminated, we have R and R in series, that gives me 2R, and this 2R and 2R are in parallel, so I have R equivalent as R. That is the answer. In D part, let us redraw the diagram. First name each point 1, this point is A, this point let be 2, 3 and 4. So I have point A over here, and from point A I have point B over here. Now B, 4, 1, 2 and 3 all are at the same potential, because you see they are connected by directly by a wire. So from 1 to A I have one resistance R, that is my this resistance. From A to 4 I have another, that is R, this is gone. From A to 3 I have another, this is again R, this is also gone. And from A to 2 I have one more, another R. So I have 4 resistance in parallel, so R equivalent is R by 4. That is the answer. In E part, let us name each of the point, that is 1, 2 and 3. That is 3 is same as that of B. So if I redraw this circuit, that is going to be A, point 1, point B and the point 2. So I have Wheatstone bridge construction, because 1A I have one resistance, between 2 and A I have another resistance, between 1 and 2 I have one resistance, that is this one, between 1 and B I have this resistance, drawn it here, and from 2 to B I have another resistance. So again it is a Wheatstone bridge construction, So net resistance can be calculated by eliminating this one. So again I had R and R in series, R and R in series, I get 2R parallel with 2R, so R equivalent comes out to be R. Again, that is the answer.